In this video, we're going to overview the Vertex compressor controller. This video is intended to provide an introduction to the Vertex control. We'll start with overviewing the control loops within the Vertex. Then we'll overview the hardware package and product offerings. We will get into the software architecture and introduce you to the graphical user interface used to navigate the GUI menus. The Vertex controller consists of 3 control loops. In general, these control loops operate independently of each other. There is the compressor section 1 anti-surge control, the compressor section 2 anti-surge control, and the performance process controller, which also includes load sharing functionality if required by the application. The anti-surge loops will keep the compressor sections away from surge while also maintaining optimal process conditions. And the performance controller provides a PID for really any process that's affected by compressor flow. So each of these control loops will take some field signal inputs, process them, and produce an output. The ASV outputs are to the anti-surge valves, and the performance demand can go to various devices. This can be a throttle valve, so it can actually be stroking the valve, or it can be a speed control set point for the speed controller on the prime mover. This is the functional diagram for the anti-surge control loops. This diagram provides an overview of the routines that affect the final anti-surge valve demand. Each anti-surge control loop consists of 4 PIDs. There's the anti-surge PID, the patented rate control PID, a suction pressure override PID, which is optional, and an optional discharge override PID. The loop also consists of surge prevention routines, such as boost, and surge recovery routines, such as SMP. There is a manual positioning ramp which allows the operator to set the valve at a desired level. And there's a sequence positioning ramp which ramps the valve output to configurable positions during startup and shutdown. Each of these routines and PIDs comes into a high signal select bus, and the highest signal of each of these independent inputs will get passed along to the final valve demand. This is the functional diagram for the performance control loop. This diagram provides an overview of the routines that affect the final performance demand. The control loop consists of 3 PIDs. There is the performance control PID, and this is controlling the main process variable. There's an optional limiter 1 PID and an optional limiter 2 PID. These are used with an independent process variable to prevent the output from allowing the process variable to exceed some predetermined set point. So for example, motor current can be used to prevent the performance demand from overpowering the motor. There's a sequence positioning ramp, and this is used to ramp the output to pre-configured values during startup and shutdown. And these signals are sent to the low signal select bus, which sends the lowest value out to the final demand. There is a manual demand ramp, and this is used to allow the operator to set the final demand at a predetermined value. And this logic contains tracking so that the manual demand and PID demands can be switched between bumplessly. If load sharing is being used, there is a separate input on the LSS. So once enabled, the load share PID demand will come in onto this LSS so that the limiter PIDs are still active, and the performance PID is actually switched off the bus. So again, tracking logic allows those modes to be enabled and disabled bumplessly. So now that we've looked at the functional diagrams from a high level, let's look at some of the applications that the Vertex can be applied to. This is an example of a single-stage motor-driven compressor with anti-surge valve control and performance process control. In this application, 5 analog inputs are used for calculation of the compressor operating point. So we've got suction temperature, suction pressure, a flow transmitter differential pressure, discharge pressure, and a discharge temperature. These 5 signals continuously calculate the compressor operating point, which then gets compared to the compressor control line or the surge control line and used to determine if any opening of the anti-surge valve is needed. The performance control loop is used to position the inlet guide vanes. So this demand will influence the amount of flow through the compressor. And in this application, the process variable is the suction pressure. So the same signal that is used in the compressor operating point calculation is used by the performance controller, and the suction pressure then is maintained to the set point. Here's an example of a 2-section steam turbine driven compressor. So this has 2 anti-surge valves that are being controlled by the Vertex and a performance process control on the section 2 discharge pressure. In this application, 4 to 20 milliamp analog inputs are used for calculation of the compressor operating point for each section. So 5 signals on section 1, 5 signals on section 2. The operating points are calculated independently for each of these sections and compared to their respective surge control lines. So these valves will modulate just based on the operating points relation to the control line for each of these sections. If a second section is used, then to accommodate the additional I/O, an RTC net node can be used. So this allows for 8 additional analog inputs, and these are sent back to the Vertex on a CAN network. The performance controller in this application is used to send the speed set point to the prime mover control. In this way, changing the speed of the compressor changes the flow through the compressor and allows a process variable to be controlled to a set point. So here we have an example of a 3-train compressor system. These trains operate in load sharing in order to maintain a common discharge header pressure to a set point. So each train consists of the motor, the 2-section compressor, and a throttle valve. The sections operating points are calculated by the Vertex controller for that train. So each train has its own Vertex control, and that is used to modulate the anti-surge valves. The throttle valve is modulated from the performance valve output, and that is used in this application to control the local discharge pressure of section 2 while operating in performance mode. So the throttle valve controls the amount of flow through the compressor in order to maintain this pressure at the set point. And then when each of these is in performance mode, they're doing that independently. When load sharing is enabled, the process variable will switch to the common discharge header process variable, and the load share logic is then used on the performance valve output to control the flow through each of these compressor trains in order to maintain this pressure, but also to distribute the load, which is typically WSPV or distance from surge, across each train equally. So when operating in load sharing, this will be maintained to the set point at the discharge header, and each of the operating points will have the same WSPV for the compressor sections. Okay, so now that we know a little bit about the control loops that exist within the Vertex and some of the applications that it can be applied to, let's take a look at the Vertex product family. There's two versions of the Vertex. There is a front panel mount, which contains the fully integrated 8-inch display with the HMI, and then there's a back panel mount version that does not contain an HMI. Now the back panel mount still has the Vertex GUI loaded onto it, so a remote PC can tie in over Ethernet and use the same display that gets launched here on the front panel mount unit. But basically, these are the two categories for the Vertex. And each of these categories has three part numbers within it. So there is a low voltage standard compliance, and low voltage is 18 to 32 volts DC. A high voltage standard compliance, which is 88 through 264 AC or 90 through 150 DC, and a low voltage full compliance, which has the ATEX and Lloyd's Marine certifications, and that's just available in a low voltage offering. And then the back panel mount has the same three options. So these are the part numbers. There's 6 here in total, and any one of these contains the same control and GUI software that can be applied to the different applications that exist. The Vertex hardware package is the same as the Flex 500 or the Flex 505 based controls. We've got 4 CAN ports. Now only one of the CAN ports is utilized in the Vertex for the expandable I/O. On port 1, we have the inlet power, and this connector will change colors based on the option available. So green will be a low voltage, and if it has an orange connector, that's a high voltage unit. There are 20 discrete inputs, 8 relay outputs, and these are Form C relays, so the contacts are built into the Vertex unit. We've got 2 actuator outputs, so these are 4 to 20 or 0 to 200 milliamp outputs, and that's configurable within the software. There's 4 to 20 milliamp analog inputs, 2 speed sensors available, and this can be either a passive NPU probe or an active prox probe per channel, and 6 analog outputs, so 4 to 20 milliamp outputs. And typically these analog outputs are what will be used to drive the anti-surge valves. There's a serial port for Modbus communications, and 4 Ethernet ports, and this is where you would tie in either the plant DCS Modbus communications or your service tools, and then load sharing is also done on the Ethernet ports here. So to expand the I/O, you can use Woodward RTCnet nodes. The Vertex is pre-configured to work with 5 nodes, and they must be of the types defined here in this table. So node ID 1 can be an analog input module, node ID 2 an additional analog input module, 3 can be an RTD module, 4 can be a discrete input module, and 5 can be a discrete output relay driver module. For the analog inputs, the part number here determines whether these channels are loop powered or self-powered channels. So you'll want to make sure you understand which transmitters you're working with and order the appropriate part number here. But the software stays the same, so the Vertex will work with either one of these part numbers. For the software architecture, the Vertex control comes with 2 applications on it that run simultaneously. So we have the Woodward Gap control application, and this is what's controlling the I/O. And then we have the Woodward GUI, or the HMI application, and this is providing the interface to the operators. The GAP and GUI applications both get launched at PowerUp. The GAP application is required to be running in order to operate the compressor. The GUI program can be stopped using a Woodward service tool called App Manager, and this does not affect the actual control of the compressor at all. So a GUI can be updated while the unit is online. This can be done to change the language on the screen. You can make an update to the GUI program So maybe you want to add some custom logos or something specific to a site. That can be done here without actually bringing the unit down. When powering up the unit, it goes through a sequence to bring both the gap and the GUI up. The initial screen will be what we call a splash screen, and this screen is visible anytime that the GUI is either stopped or initializing. So on initial power up, the gap will begin to run, and at that point the compressor can be operated. Once the gap is up, you will see the alarm light flashing. So this is flashing and you see a splash screen. That means that the GUI program is initializing. If you ever get to the point where the alarm LED is solid and the splash screen is up, that means that the GUI is either stopped or something occurred during initialization and it wasn't able to launch. So it does take a little bit of time to bring the GUI up. After about 6 minutes, the screen will go from the splash screen and into the home screen. The first time that the unit boots up, it will display this screen shown here. So it says Vertex unit is not configured. When you see this screen, you know that the unit has default values from the factory. And then once you go in and start configuring the unit and the compressor map is successfully defined, this home page will actually change to the runtime menu screen. So this is where you can access the different runtime operational screens. The Vertex consists of 4 user levels and 3 modes. User levels provide the user authority or determine what values within the control the operator is currently authorized to use. The modes are dependent on the state of the controller. Modes are restricted so that only the proper user level can change the mode of the control. The operational mode is the typical mode of the control after it's been commissioned. This mode allows the operator to operate the compressor from startup through shutdown. And the calibration mode is only available when the unit is not in IO lock but shut down. And this requires at least service user level. The calibration mode is used to calibrate your analog inputs and your outputs. So it allows for forcing, and the relay outputs can also be forced in this mode. And this will be done to verify the signals going to and from other devices in the system. Configuration mode requires the unit to be shut down and in IO lock, and that means that all outputs are de-energized. So analog outputs will be 0 milliamps and relay outputs will be in the de-energized state. Configuration mode is required to change any of the configuration parameters within the Vertex, and you must be logged in at least at the configure user level to access this mode. So changing modes and user levels is done from the mode screen. This can be launched by pressing the mode button built into the front panel of the Vertex unit, and this screen can be accessed at any time from any page. To log in, you need to just simply press the login soft key, and the pop-up will be launched to allow you to enter a user level and the password for that user level. These autofill keys save you the time of having to type in the user levels. So these user levels come defaulted in the control, and pressing this key will populate the user level here, and then you just need to enter the passwords. The passwords are listed in volume 2 of the manual, and once it's entered, press the login key and you will see your user level here back on the mode screen change to reflect the user level you just logged in with. The components throughout the GUI are authorized based on the user login level. For example, configuration parameters require the user to be logged in at the configure user level. The components on the GUI provide visual feedback whether the current login level is authorized for access. So if adjustment is authorized on an analog value, the adjust arrows are visible. And if you're unauthorized or your user level is not high enough, the adjustment arrows will disappear. For Boolean values, say a checkbox, the background of the checkbox will be black if it's authorized, and if access is not authorized, it will be grayed out here, and you are not able to edit that particular parameter. So because this unit is not a touchscreen, navigation between pages and components within the GUI are done using the front panel navigation cross. So an in-focus highlighter is available on each screen. Typically when you go to a screen, the in-focus highlighter is not there. You have to press a navigation arrow, and then the focus will move to the first component on the screen, and once it's got that yellow highlighter around it, it can be interfaced with from the navigation cross or the front panel keypad. This in-focus highlighter can be moved from one component to another on the screen using the up, down, and left-right arrows. So typically the screens are laid out in a fashion that is intuitive where that focus will go when you press a navigation key. So for example, if you're on the home screen and you want to change to a runtime page, you would use the arrow buttons to move the in-focus highlighter to a particular page, press enter, and you will be moved to that new screen. Pressing escape always returns you to the previous screen you were just on, and pressing home returns you to the menu of the GUI. So if you're in the configuration menu and you go into a configuration screen, pressing home once will return you back to the configuration menu, and pressing home again always returns you back to the original home screen of the unit. In general, green keys on the front panel and for buttons within the GUI are used to issue operational commands. The red or maroon keys are used to navigate to different pages or pop-ups. The black keys along the bottom of the display are called the soft keys, and these are always active, so they don't require the in-focus navigator to interface with the buttons that are just above these, and these will change for each page of the GUI. There are three primary menus within the GUI interface. There is the Home or Runtime menu, which provides navigation to the various pages used to operate the compressor controller. There is the Service menu, which provides online access to control settings or special features of the control, such as the data log. And there is the Configuration menu, which contains navigation to all configuration pages. The values within the configuration menu can only be adjusted when the unit is in configuration mode, but they can be viewed at any time. So here we'll do a quick demo of the Vertex GUI pages. This will cover some of the same topics we just went through in the slide deck, but do it with a running unit. So here I've come up to the home screen. It doesn't say unit is not configured, and we have the runtime pages available. So we know that this is a configured unit. Now the runtime pages that get shown here will adjust based on the configuration of the Vertex controller. So here we've got a single section compressor control with a performance loop. If load sharing or a second section were configured, those operating pages would have been displayed here. So the little number up in the top right of these runtime page buttons relates to the hotkey that can be used to jump over to that page. So if I come to the keypad and press the number 1, that'll jump me over to the overview page, and if I press 3, that'll jump me over to the anti-surge control page. So those numbers relate to the hotkeys associated with those pages. As we said before, the GUI is structured with 3 menus. So here is the runtime main menu, and I can access the configuration menu and service menu from this main menu. If we go into the configuration menu, we see all of the different categories for configuration of the Vertex. So we have an overall train configuration page, a performance page, performance limiter page, load sharing, and then our compressor specific configuration. Each of these menus can be opened and viewed or adjusted if you're in configuration mode, and then pressing home will take you back to the menu that you're currently within. So pressing home once goes back to the configuration menu, and pressing home again takes you back to the main menu. I can go back into the service menu here, and similar structure. The different control loops can be accessed, and the parameters, which can be tuned while the unit is online, are displayed here. So if we need to make an adjustment, that can be done. Pressing home takes you back to the service menu, and pressing home again takes you back to the main menu. If I want to log into the unit, I can press mode from any screen, and I'll be taken to the user login and mode selection page. So currently I'm logged in at the configure user level, and the mode is the operation mode, so we are actually running or can run the compressor. Pressing the login soft key will launch the user login pop-up menu. Here we can log out of a current level, or we can log into a new level. So if I press log out, you'll see that my user level has changed, and now I'm in the monitor mode. If I go to, say, service menu, I should not be able to access any of these parameters, so these checkboxes are now grayed out, and the adjustment arrows have disappeared. So I know that I can't tune anything on this page. Going back into the mode screen here, I can log in now with a new user level. So I will auto-populate the user level name. I'll navigate over to the password block, press enter, and then I can enter the password for that user level. These passwords are listed out in the manual volume 2 for reference, and once entered, pressing login will take you to that new user level.